Here's a dumb and useless fact to start us off. We were just talking about tornadoes, and this lesson we'll talk about hurricanes. And the fear of swirling winds is called lapsophobia. The term hurricane comes from the natives of the West Indies, and it means God of evil. It's a large, windy, spinning thunderstorm that forms over the ocean. And they need to form over the ocean because hurricanes have to have two things: warm water and rising air. Rising air makes clouds, and that warm water provides warm air at the surface and instability to cause that air to rise. This is a picture taken from space of a hurricane, and it's not one solid thunderstorm. It's made of spiral rain bands, and then usually in the center there's an eye wall where the strongest winds are, and then a calm, clear eye. If you've ever seen a little tornado form in a bathtub or sink, and you look straight down into it, you can see there's an area there for the air to come out of the pipe in the sink. Well, hurricanes flip that upside down, works basically the same way. They can form many different places on Earth, and they're called different names depending on where they form. In the Atlantic and the Eastern Pacific, close to North America, they're called hurricanes. Once they cross the international date line, they're called typhoons. They're called cyclones in the Indian Ocean, and a long time ago, around Australia, they called them willy willies. But today they're also tropical systems. If we look on the Earth from the South Pole, Antarctica's in the middle, and we mark the equator there with a dotted line, you can see the abundance of hurricanes we know about since 1851 have occurred north of the equator. They're moving in tropical areas. That means they follow the trade winds from east to west. Here in the United States, from 1950 to 2014, you can see that a lot of places in the Gulf of Mexico experienced a landfalling hurricane. That's because the Gulf of Mexico is trying to kill us. Florida's had a number as it sticks right out into the Gulf of Mexico, and then also the eastern seaboard in the Carolinas have received a fair number of hurricanes, with a couple making it all the way up to New England. Hurricanes are big, low-pressure areas. And low-pressure areas rotate cyclonic in the north and clockwise in the south. This is a hurricane in the southern hemisphere, one of two that we know of historically in the southern Atlantic Ocean. It's just too cold in the southern Atlantic to get a hurricane. But this happened off the coast of Brazil. Here's a movie of one developing and forming off the coast of Australia. So that means they will rotate clockwise. As it gets more and more organized, eventually you will see the eye and the eye wall form. And as it gets close to Australia, the colors you see are from the radars monitoring the precipitation from this system. Here's a satellite picture from 1995, and you can see quite a few tropical systems on that picture. Here again, they're moving from east to west, but as they drift far enough north, they'll then turn back to the east. And the question is, why does this happen? Well, don't forget from our lesson on global winds, weather systems in the United States move west to east. So as the hurricane moves off to the north, it's going to be affected by those global winds. So it gives it the appearance that it comes out of the Gulf, and then before it hits North America, it goes back out to sea. Hurricane formation is complicated, but it starts as a large mass of thunderstorms, known as a tropical disturbance. It has a cyclonic spin to it. As it gets more developed and the rotation intensifies, it becomes a tropical depression. The central pressure starts to get lower and lower, thus depression. Winds typically in a tropical depression will be a little under 35 miles an hour. Once we get a sustained wind of 40, 50, 60 miles an hour, the system becomes a tropical storm and it gets a name. Winds over 74 become a hurricane. Off on the left is the symbol for a hurricane. It's a dot with two arms sticking out of it. A tropical storm was a hollow dot with two arms. A tropical depression was a fancy little L. If you slice a hurricane in half, again, it looks solid from the top, but it's really made of rows and rows of rain bands. The closer you get to the center of a hurricane, the more intense the rain and wind becomes. This is a radar picture of Hurricane Andrew as it came on shore in southern Florida. The little cross in the picture with the NHC underneath stands for the National Hurricane Center. This hurricane was so strong it actually blew the anemometer off the roof of the National Hurricane Center. The people in Elliott Key right now have very little wind and clear skies because they are in the eye of the hurricane. The most intense part of that hurricane is surrounding the eye in the eye wall. The eye wall has the most intense winds because its rotation is the fastest. And Drew did a good demonstration about this at the Leicester Science Factory.
I got a cool demo for you guys. We got some balls right there. Scientists help me out. What she's doing is she's taking these balls and they're going for a roll, and look how it's a big circle right there. Well, we talked about the farther you are from the center, the slower you go. So what I want you to watch is as these balls get closer to the center, where it's a lot smaller and kind of looks like a tornado, they will be moving faster. So keep an eye on the speed and watch as the ones get closer to the center, they move a lot faster than the ones out here. So look at this one. This one's moving slowly. Look how that right there is moving a lot faster compared to this one right there. Let's look at it one more time. Look at that. Look how it's moving faster. You're closer to the center of the rotation, so you're moving faster. It's like putting your arms inward when you're spinning in a chair with weights. Look how fast that's going right now. Look at that. Just letting her rip versus that one right there. So when you're farther out from the center and you're spinning, you move a lot slower. When you're closer in, just like this, you are just racing along, and down the balls go out into this machine. How cool is that?
Hurricane Katrina was a real bad hurricane for the Gulf Coast. And this is a video of its formation. It was a tropical storm as it approaches Florida there on the east or right side of the screen. Then it crossed over the mainland of Florida, and when it got into the warm water of the Gulf of Mexico, look at how quickly it explodes. You're going to see a clearly well-defined eye in the middle of the hurricane. And notice the size of this complex. This storm is as large as the Gulf of Mexico, as large as the state of Florida. Hurricanes are large, large systems, and they affect many, many people. There's a lot of energy behind a hurricane, so a dumb and useless fact. If we could harness the amount of energy released in a hurricane, it could power the entire United States for 3 years. Hurricanes die out when they hit the land. Why do you think that is? Well, remember what a hurricane needs. It needs warm water, and there's no water on the land. They need warm water to keep going. So this is a complicated radar picture that we're going to be looking at. There's a couple things you can see. In the upper left corner is the date. The color of the water indicates the warmth of the water. Blue is cold, orange is warm, red is extremely warm. Then we're going to go ahead and put the clouds on top of it. And when a hurricane forms, you're going to see a line and trace out the path that it follows. So the movie is going to move kind of fast. And we'll start with tropical system Arlene. The names go in alphabetical order. And as we go through June into the month of July, you're going to notice the water will get warmer and warmer. That's where Cindy develops and Dennis both move through the Gulf and come on land. That's followed by Emily and Franklin. Notice how warm the water is getting around Florida as Harvey and Irene are out in the Atlantic. That extremely warm water sets the stage for the formation of Hurricane Katrina. As soon as the disturbance hits the Bahamas, it explodes, and then it churns up the water behind it and cools it off. Lee and Maria wander out in the Atlantic again with Nate and Ophelia. Hurricanes can do that as well. And then Rita becomes a powerful hurricane that affects Houston, Texas. Then there's Stan and Tammy. And then the strongest hurricane in the Atlantic basin to that point is Wilma. After W, they've run out of letters, so they go to the Greek alphabet of alpha, then beta, gamma. 2005 was an intense season for hurricanes. Not all are that busy. In fact, if we go back to 1851, you can see when tropical storms, hurricanes, and major hurricanes tend to form. And they're at their peak right around or just after Labor Day. At the time when the risk for hurricanes is elevated, we call that the hurricane season in the Atlantic Basin. The strength of a hurricane has to be measured inside the storm system itself. So the National Weather Service has these planes with hurricane hunters that fly into the system and release balloons down into the hurricane to measure temperature at pressures at different depths. This is a movie from the inside of that powerful eye wall of Hurricane Katrina. A friend of mine who flew into Katrina on one of these missions described it as if you were standing on the field at Beaver Stadium at Penn State. The clouds don't go straight up like a wall, they kind of curve away from you. Notice how clear it is up above. So we have sinking air here, which inhibits the formation of clouds. And it could look like this from the ground as well.
There's birds. What?
This is a movie from Hurricane Elena, way back in 1985.
It's blue, straight up. Look,
But they're inside the eye of the hurricane right now.
Is that the eye wall? Look at that blue sky. God. We are right in the center of it. You can't get any more center than this.
As the eye comes on shore, there's no more warm water as the source of its fuel, and it begins to die out. Like tornadoes, hurricanes can be of different strengths. And we use the Saffir-Simpson scale to measure the intensity of a hurricane. And just like the Fujita scale, it goes from 0 to 5, where category 1 is the least destructive, all the way up to category 5. What's different about the Saffir-Simpson scale compared to the Fujita scale is the Fujita scale is measured after a tornado causes damage. But a Saffir-Simpson scale is used while the hurricane's out to sea. And they use it to try to inform the public as to how bad the damage could be before the hurricane comes on shore. Most hurricanes that have come on shore have been Category 3 or less, but there are those handful of storms that cause enough destruction at a 4 or a 5.